Many beginning stoichiometry problems will give you a known mass of one chemical and ask you to calculate another. For example, let's say our question gives us 5.27 grams of the octane molecule and is asking for how many grams of carbon dioxide that would produce. In all of the cases of these problems, you need to convert your given quantity into moles before you convert those moles into other kinds of moles. You can think of the moles as your universal translators. Have a periodic table handy. You're going to need molar mass values. For the octane, we have 8 carbons, and carbon has a molar mass of 12.01 grams per mole. And we have 18 hydrogens, which have a molar mass of 1.007 grams per mole. And we're going to need our carbon dioxide numbers as well, so we might as well do it now. 1 times 12.01 for the carbon, and since there are 2 oxygens, 2 times 16. Okay, that gives us a molar mass of 114.206 for the octane and 44.01 for the carbon dioxide. Okay, so now what we're going to do is set up our problem in a dimensional analysis type of way. We'll write down 5.27 grams, our starting number, and then follow the idea that these grams need to be converted into moles. Okay? So I will divide by our molar mass, 114.206 grams of this stuff per mole. Please notice how I'm taking the time to write out the chemical formula. This will save you a lot of confusion later. Okay, now that I have my octane molecule in moles of octane instead of grams, I can do the mole-to-mole ratio trick that we learned last time. 2 moles of octane, which I'm getting from the balanced chemical equation, to 16 moles of carbon dioxide. Also getting that number from the balanced chemical equation. Now that I have changed my type of chemicals, I can move towards answering my original question, my grams of carbon dioxide. Okay, to convert moles of carbon dioxide to grams of carbon dioxide, all I need to do is multiply by the molar mass. For every 1 mole of CO2, I have 44.0 grams of CO2. To complete the question, we just need to multiply across the top and divide by each answer on the bottom to get 16.2 grams of carbon dioxide. Now I want to bring your attention back to the structure of this dimensional analysis. The first chunk of our question is converting grams into moles. The next chunk is converting from one type of mole to a different kind of mole, using those balanced chemical equation stoichiometric coefficients. The last part is just answering the question. In this case, we had to convert our moles back to grams. Make sure that you master 3 or 4 of these types of problems before moving on to the ones with interesting tricks.